Don't look at me.
I didn't look at you.
I don't know why.
We all kind of looked at you.
Why did y'all assume it was me? I don't know. I just thought it was me.
Okay, so on 1 through 6, it tells you that you can solve them using any method, and you can. Tomorrow you'll be able, on your test, you'll be able to solve them using any method. I'm going to just do them the way I did them. If you do them differently, that's okay. You can do it any method you want. So in number 1, we had x squared plus 12x plus 35 equals 0. And I know I saw a lot of people all day long doing the quadratic formula on that. That will work. That's fine. I did that one by factoring. So I'm going to do it the way I did it. I knew 1 times 35, the factors of 35 that add to 12 are 5 and 7. So this factors as x plus 5 times x plus 7. When I set both of those equal to 0 and solve, I get a -5 and a -7, which is what you got if you did the quadratic formula. So don't think you have to change and do it my way. Okay? Anybody do the quadratic formula and not get that? You need me to help you find where your mistake is? What'd you get, Graham?
I got x equals -2 and x equals -4.
Uh-oh. Uh-oh. Oh, you can't. This should still be a -12. You can't divide part by 2 now and part later. You got to divide it all at once. So you would need to do the -12 plus 2 is -10. Divide by 2 is -5.
Okay.
All right. So number 2, a lot of people did the quadratic formula on number 2 using a b of 0. So if you wanted to do quadratic formula on number 2, your a would be 3. Your b would be 0, and your c would be -48. That will work. I'm going to do it a different way. Easiest thing to do when your b is 0 is just get the x all by itself. So we could move that 48 over. So we'd have 3x squared equals 48. Then undo the multiplication of 3. So we'd have x squared equals 16. Then undo the squared by square rooting. Square root of 16 can be positive or -4. Alright, got a couple still writing on that, no problemo. On number 3, when I worked it the first time, x squared plus 10x plus 25 equals 64. First thing I did was move the 64 over to set it equal to 0. And then after that, I factored it. But Grant showed me that this is ready, as it is, to be completing the square. Okay, so if we went through and did them all how they're set up, this one is set up perfect for completing the square. Because x squared is a perfect square. Square root of 25 is 5. It's a perfect square. And 5 is half of 10. So when we did completing the square, we just took the square root of the first one, brought down the first sign, took the square root of the last one, and it looked like that. Now you, again, did not have to do it this way, but this is the way it was set up. It was kind of easier to go here. So now Grant remembered all we had to do to get rid of that square was to square root everything. So x plus 5 square root of 64 can be positive or -8. The last couple of steps, you got to subtract 5. But remember, you got to subtract 5 from the 8. And you got to subtract 5 from the -8. So you would get a 3 and a negative 13. I was super excited when Grant noticed that that's how that one was set up yesterday, because I didn't notice it. Pretty cool. Everybody do the quadratic formula and not get that, need to figure out where you went wrong? I'm going to try to help.
That's what I'll do.
Alright, 4 is the only one that out of these 6 that had a funny answer, so let's do 4. Well, maybe 6 did, maybe, but 4 is the funniest, the ugliest. Let's look at 4. We got negative 3x squared minus 5x equals 5. Alright, what did you need to do on this one?
When you subtract 1.
Okay, Lady Jo's going to move the 5 over, so she's going to rewrite this as negative 3x squared minus 5x minus 5 equals 0. I had some people added the 3x squared and added the 5x. So either way would work. The way Lady Jo did it, you only had to move one thing, so that was less work. So now, there's not a lot of choices for me on this. I would just be doing the quadratic formula for sure. So the way we set it up here, my A is negative 3, my B is negative 5, and my C is negative 5. So here we go with our quadratic formula. X equals negative B plus or minus the square root of B squared minus 4AC all over 2A. I don't think it's this class, but I'm going to try to remember to say it in all of them because I can't remember for sure which class it is. But a lot of people, when they're writing the quadratic formula, are writing B squared plus 4AC. We need to fix that. That's always a minus. B squared minus 4AC. It's always minus 4. If that was anybody in here. I saw that a lot yesterday. Alright, so that gets me 25. 4 times 3 is 12, 5, 60. So 25 minus 60. And that is negative 35. Okay. Believe it or not, there's only one thing I can do to simplify that. 35 is not a perfect square. I can look over there by a river on the board. They wrote down a lot of perfect squares. 35 is not on that list on the right side. And there's not any on the right side that go evenly into it. You know, we always had to check and see if we could break it down, see if somebody could come out and play wiffle ball, and anybody had to stay in the house. But there's not anybody that gets to come out and play wiffle ball. So the 35 has to stay in the house. Go ahead and tell me what you were fixing to when I cut you off. What do I need to do?
Take the negative out.
Very good. When you got a negative underneath the square root, change it positive and bring an I out. So your final answer here would be x equals 5 plus or minus I square root of 35 all over negative 6. Around. Number 5. Got what we need on that one? Number 5, I got 4x squared plus 3x minus 10 is equal to 0. I didn't even think about another method here. I just did what I think most of y'all did on this one is the quadratic formula. Is that about right? So you had an A of 4, a B of 3 is already in standard form, nice and neat for you. So we go x equals negative b plus or minus the square root of b squared minus 4ac over 2a. Alrighty. So let's simplify that up. Negative 3 plus or minus the square root of 9. 4 times 4 is 16, times 10 is 160, and that negative times a negative means that's plus 160. And then wouldn't you know it, 160 plus 9 is a perfect square. 169 over there by Rivers says the square root of that is 13. So we're going to do negative 3 plus 13 and then divide it by 8, and negative 3 minus 13 and divide it by 8. So negative 3 plus 13 is 10. 10 divided by 8, that's a fraction or a decimal. So you can put it as 1.25 if you want to. I just left mine as 5 over 4. But 5 over 4, 1 and 1/4, 1.25, all of those are right. And then negative 3 minus 13 is negative 16. Negative 16 divided by 8 is negative 2. What you got, Laney Joe?
Okay, so I just mine a little different, but I got the same answer. But is it when you do A times C here and the common factors of B?
Very good. So you factored by grouping. Good job. I like it.
Okay, that was my question.
Yep, yep. Not many students choose factor by grouping. Pretty impressive. Pretty impressive.
It's so cool. Well, I just remembered it from house.
Yeah, I don't hear you loud and clear.
No.
I don't hear you loud and clear.
No, I don't either. It's all I do. It always bothers me.
Man, what's that all about?
No.
Does Garrett read aloud or something?
Oh my gosh. He broke his nose like 6 times. So every time he breathes, it's like a struggle.
Okie dokie, number 6. Okay, 36x squared plus 49 is equal to 0. I saw several people do this like they did on number 2. They made their A be 36, their B be 0, and their C be 49. You can do that, that works. I'm going to do it the same way I did on number 2, though. Whenever I don't have a B, I just solve it algebraically. So I'm going to subtract the 49 from both sides. I'm going to leave mine as a fraction, and I'm going to try to explain to you why. Okay, that's what I got when I subtracted the 49. Now my x is being multiplied by 36, so I have to undo that with division by 36. Now this is what Grant was talking about, and here's what I want you to see. Over on the left side, your 36 divided by 36 is canceling out, so you just have x squared left. So if you just have x squared left, that means at some point you're going to have to take a square root. But look at this division problem that I've got on the right side. If I'm thinking about taking a square root, aren't both those numerators and denominators perfect squares?
Yes.
So I'm going to leave that in the fraction like it is. Because those are pretty perfect squares for me. So now when I undo that squared and square root both sides, the square root of 49 is 7. The square root of 36 is 6. Since there was a negative, what do I get when I square root? That's right, say it louder.
An I.
An I. And anytime I square root, I can be positive or negative. That's it. A lot of people did what I heard y'all say. They did that 49 divided by 36 and then didn't know what to do with that decimal. You got to kind of think ahead a step and know, well, I'm fixing a square root, and 49 and 36 are friendly, so think ahead. Plan ahead. Take your raincoat.
Rain.
Do you bring an umbrella today? Just wondering if it was in the south part of the state. I don't know if it's going to make it up here, but they said it would.
I'll look.
Man, am I going to the fair house there?
I know, because I saw.
Maybe it'll stay south until they leave. Maybe.
It did last year.
I don't want to rain on it.
Well, yeah, it rained like week. I just got to leave class to take this. Wait, do they still do rides when it's raining?
Oh no. I wouldn't think so.
No. The smaller ones.
Alright, 7 through 10 were some of the easiest ones. Actually, this 7 through 10 and then 12 and 13 I would say are the easiest 6 on the test. All it asks you for on 7 through 10 are the number and type of solutions. It doesn't ask you to actually solve. So your choices here, there could be 2 real solutions. There could be 1 real, this is number and type, or there could be 2 imaginary. That's all you have to decide on 7 through 10. Are there 2 real solutions? Are there 1 real solution? Or are there 2 imaginary solutions? So when I look at number 7, I see that parabola crosses the x-axis twice. So that means it has 2 real solutions. That's all you have to do on that. On number 8, I see that thing, it only touches the x-axis once. So it has one real solution. Yep. Number 9, my graphs are getting smaller. Number 9 never touches the x-axis. So it can't have any real, which means it has to have 2 imaginary solutions. And then on the last one, on number 10, that thing crosses it twice. So just like number 7, it has 2 real solutions.
The rain's not going to stay south.
It's headed our way.
It's headed right toward them.
Well, I guess they can huddle up under a canopy or
They can just
pavilion. All that fried food.
They'll live.
I remember back in the olden days when the only food you got at the fair was either cotton candy or a corn dog. There's nothing wrong with it. Why did they have to decide to start deep frying everything possible?
Literally.
Man.
They deep fry the ice cream there.
Yeah, I don't know how they do that. That's like super possible.
It's good.
I don't know, it ought to just
They,
melt.
It's not
they,
how it doesn't melt.
they put
That's what I
cinnamon.
said.
They put cinnamon around it. They fry the cinnamon and they put it around it.
Okay, well, what if you can't have cinnamon? Then you can't even eat it.
You have a point.
Riley's getting fired up. Let's not go there.
I mean, and I thought it would like you not have a cinnamon.
Oh my.
Oh, no.
Put them in your lemonade.
Yeah, I'd probably eat them just because it's deep fried.
Fried egg. Absolutely fine.
Okay, so number 11, a golf ball is hit from the ground and its height can be modeled by that equation. H of t represents the height in feet of the ball, t seconds after contact. So it says, what's the maximum of the height of the ball going to be? So there's like what your ball flight would look like. You hit it from the ground, it takes off, and then it comes back down. So you're looking for this value up here on the maximum, which happens at the vertex. It is on the y of the vertex. So we're looking for the y of the vertex. So this equation that they gave you is in standard form. So we can find the axis of symmetry, or the x, by doing your negative b over 2a. Now be real careful on the test tomorrow. This question asks for the max, so we need the y. If it asked for the distance, we would use the x. So you make sure you answer the question right. Okay. So I'm going to do, my b is 128, so I'm going to do negative 128 over 2 times my a is negative 16. That negative by negative turns into a positive, which makes sense because we're talking about a golf ball over time. We can't have any negatives here. 128 divided by 32, I believe, is 4.
Yep.
So that means that my ball's highest point is going to happen 4 feet away from me. So I'm hitting a pretty short high shot, like a sand wedge or something. So to figure out how high now, or how long it takes it to get there, my bad, I got to plug that 4. Yes, and I said all of that wrong. That 4 is seconds. Because t was time in seconds. So 4 seconds after I hit the ball is when it gets its highest. Thank you for fixing me up on that, Riley. Oh, it's 128 times 4. And I did all that, and I found out my golf ball is going very high. Did y'all get 256 feet? You want to plug it in and check me out? That's what I got when I worked on it yesterday. Okay. 12 and 13 are pretty easy. I was surprised throughout the day yesterday how many people had forgotten what to do on them. People actually tried to multiply both of them. 12, it's got a subtraction sign. So don't multiply on 12. Just subtract your like terms. Everybody got what we need on the golf ball problem? Ready to move on to 12? All right, all right, all right. 1 minus I minus 4 minus 5i. So all we're looking at here is take your real numbers and subtract them. So 1 minus 4. And then take your imaginary numbers and subtract them. So that is a negative 1i. So I got negative 1i minus negative 5i. Which that turns that to an add, so that makes that be a positive 4i. It said to write your answer in standard form. Is this standard form? Anybody remember?
Yes.
Yep.
Yes, it is. The real goes first and the imaginary goes second. So that's all you had to do on number 12. That's what I should have dressed up like. Then I've had to do like panda skin. Some people would say that's racist. I don't know if that is or not. I don't think I consider that. Do you consider that racist? Because you're just trying to be like that. It's not like you can be making fun of them.
Yeah,
Yeah,
really
yeah,
good of
but-
them.
But other people,
Yeah.
Someone's always
Would I think it was racist if a black person painted their skin white?
This is too stuff. This is
This is true stuff. I just
Good English.
I just think of like saltine cracker. I don't know. I guess you gotta be careful in this politically correct society today. All I was thinking of was I was having the fat part down, so I just need to be a light person. Okay, so 13, we do have to multiply because there is no sign between the two parentheses. So you can say it however you want. Distribute the negative 4 to everything in the second parentheses. Distribute the 5i to everything in the parentheses. When I did these with you in class, I used the FOIL, an acronym, which is the same thing as distributing. I want to take the first one times the first one. So negative 4 times 5 gets me negative 20. And I'm going to go on the outer edges. Negative 4 times negative I gets me a positive 4i. 4i's off. That's me. So I'm done distributing the negative 4 now. I'm going to the 5i. Enter. 5i times 5 is 25i.
I don't know where it is.
What?
It's telling me to wake up.
Oh, that's a bit late.
that's a good thing.
It's a little bit late.
Whew. 5i times negative I on my last is negative 5i squared. Alright, so combine those like terms. That gets me 29i. Not many people remembered yesterday what I squared was the same as.
Isn't it just negative 1?
Very good. So that minus 5, change your I squared every time to negative 1. Now that makes that negative times a negative a positive. So you've got
Doesn't it end up as negative 15?
one more piece of like terms. Your negative 20 and your positive 5 is negative 15. That's your final answer. You got it. You got it. Woohoo! Woohoo!
Questions done.
I'm gonna rate that.
I gotta quit sitting down, that's lazy. I kind of enjoyed it though. I don't ever sit down. Just kind of small and relaxed today. Okay, 14 and 15 are probably the ones that took me the most time. You ready, Freddie? Alright. 14, come on, page, there we go. 14, I've got negative 2 squared plus y equals 1. And then on the other one, I've got y equals x minus 1 squared plus 3. So on these two, 14 and 15, it's told you to solve the system. So this is the ones we did where we have to find the intersection points. Thank you. So we're looking for where these are two parabolas. We're looking for where they're going to intersect. Okay? This one is set up for substitution because that bottom equation has the y all by itself. So I can take that and substitute it in the other equation for the y. Now, why this one is a little bit more complicated is because of that x minus 1 squared piece. Remember I told you can't just square the x and the 1. You have to write that x minus 1 twice and multiply it out. So that'd be x squared, negative x, and negative x is negative 2x plus 1. And then it also has a plus 3 on the end. So that would make x squared minus 2x plus 4. So this is what y is the same as. When I wrote that x minus 1 twice and multiplied it out, I know I multiplied it out real fast, but you can go through your steps and distribute it. So I'm going to take what's over there by Grant on the dry erase board, and I'm going to plug it in up here in this first equation for the y. So I would have negative 2x squared plus, and for y I got to write all that in, x squared minus 2x plus 4 equals, and then it was an equal 1 up there. Okay, so now you've got some like terms to combine. Look at those x squareds. Negative 2x squared plus 1x squared gives you negative 1x squared. Okay, so we've almost got a quadratic in standard form. What could I do to get this thing in standard form? Good. So that would give me negative x squared minus 2x plus 3 is equal to 0. Okay, if you want to use that quadratic and go to the quadratic formula with an a of negative 1, a b of negative 2, and a c of 3, it will work. I did a little trick because I like my a to always be positive. So I just multiplied that whole equation by negative 1 and changed all the signs. You don't have to do that, but that helped me see that it's factorable. Because now I'm looking for the factors of negative 3 that add to 2. And so I know I can rewrite this as x plus 3 times x minus 1. So my zeros end up being negative 3 and positive 1. Okay, but here's the bad news. This problem, we were told to find the solution. We're looking for where this stuff intersects. So it's going to intersect at negative 3 comma something, and then 1 comma something. So I have to go back to one of my original equations now and plug those two x's in. Alright, so I'm going to scroll back up here. Doesn't matter which one you plug it in. I'm just going to plug it in this bottom one since it's already got the y by itself. So negative 3 minus 1 is negative 4. Negative 4 squared is 16. 16 plus 3 is 19. So there's one of my ordered pair. Now I'm going to plug the 1 in. 1 minus 1 is 0. 0 squared is 0. 0 plus 3 is 3. So there's your two answers.
But how would you do it if you did the quadratic formula?
You should still get these two x's. So you would have done your a is negative, where are we at right here? Your a is negative 1, your b is negative 2, your c is 3, and you would still get to these two x's. Mm-hmm. And then you would have to plug them in. Did you not get?
No, I got 8 and 2.
I'm going to guess and say, when you typed that in, did you put that in parentheses?
No.
That's fine. Yep, you have to put that in parentheses or it'll do it wrong. Alright, 15. 15, I got 4x minus y equals 4. And then I got x squared minus y equals negative 1. What I noticed on this one, I did it differently than we did in class. In class, I would have substituted this one in, but I said, hey, both of those y's are a 1. Can't I just go ahead and eliminate them? And I can, and I'm going to, but I got to be very careful with my other stuff. The y's have same signs, which means I'm going to subtract. I want to try to keep this thing in standard form, and in standard form the x squared goes first. So this is where it gets tricky. Look at this top equation. What's my x squared value up here where my mouse is? 0. So I got 0x squared minus 1x squared. So that's going to make that a negative x squared. Then I got 4x minus 0x, so positive 4x. Negative y minus negative y is nothing. He gone. 4 minus negative 1 is 5. And now you can subtract that 5 to move it over. I chose to move the other stuff over to keep my a positive, so I had x squared minus 4x plus 5 is equal to 0. And that was really tricky to me because I really wanted to say that could factor, but it can't. There's nothing that multiplies to make 5 and adds to make negative 4.
I have a question.
If it were a negative 5, it could. Go ahead, Angel.
That makes a negative 5, isn't it? Because when you have to subtract 5.
Hold on. If you wrote it that way, it is a negative 5. But then you would be looking at what multiplies to make positive 5 and adds to make 4. And there's nothing that does that either. So the way I've written it, I just chose to move the other stuff over, but it's still the same. So still the same stuff. Alright, so quadratic formula it is. So x equals negative b plus minus the square root of b squared minus 4ac all over 2a. Okay, so I already know the answer now. You do too. Remember when we're looking for a place to intersect, if we can't see it, they don't intersect. What can we not see? Imaginary numbers. 16 minus 20 is negative 4. When you get a negative underneath the radical, it's imaginary. If this had said to solve, like on the first page, we would leave our answer with an I in it. But this one, we were trying to find an intersection. We were trying to find 2 equations where they intersected. So as soon as we get a negative underneath there, just like we did in that day in class, we can say no solution. Woohoo! Alright, 16 and 17 are the scribbling ones. Everybody's favorite. Y'all love the scribbling day. I remember it like yesterday. Even though it wasn't. Yesterday's plain awful.
Fun.
Let's say that.
I'm
Okay, know that movie? Annie. I don't know if it's in the new one or not, but it's in the original one. So, chocolate in the little
Do you remember the guy that had his
yeah.
fro?
That hair was something.
That's what I used to call it.
Okay, so to graph this thing, that's in almost standard form. It's not like it is. Standard form is y equals ax squared plus bx plus c. So I need to move the 5 over and I need to move the y over. So I'm going to rewrite this as 3x squared minus 5 is greater than y. Okay, I subtracted the 5 and I added the y. Everybody see what I did there? So now we're in standard form, and our vertex, we always find our axis of symmetry by doing negative b over 2a. What's our b in this case? 5. Nope. Somebody, 0, right? ax squared bx, there's no x in the first, so my b is 0. So to get my axis of symmetry, I'm doing 0 divided by 6, which is 0. So now I have to plug that 0 in to get my y. Well, 0 squared times 3 is 0, so 0 minus 5 is negative 5. So there's your vertex. So we're going to go over 0 and down 5. Now look at the little grid they gave you. They counted by 2s. So I'll try to count the way they did so you know what's going on. They counted by 2s. So 2, 4, and then a half. So there would be your 0, 5. Okay, now you just need to pick some other x that's in the ballpark. So if we got an x at 0 right here, how about we pick a 1? So I'm going to plug a 1 in right here. 1 squared is 1 times 3 is 3. 3 minus 5 is negative 2. Now this got tricky to count because they counted by 2's. So if I go right 1 and then down 2, be right there. And then make that equidistant on the other side of your axis of symmetry. Now, do you need to draw this parabola with a solid curve or a dashed curve? Good, Hunter. Dashed. So this is a narrow one. Now we got to figure out if we're supposed to shade on the inside or the outside. So I cautioned you to pick a test point within. So I'm going to test 0, 0. And I can just plug it right here in this sentence if I want to. 0 squared, so that's just going to be negative 5. So that says negative 5 is greater than 0.
Yeah.
False. So negative, right, Lady Joe, is not bigger than 0. So I can't shade 0, 0. So I can't shade on the inside.
You gotta shade everywhere.
So you got to shade all around the outside. Beautiful, beautiful, beautiful. Not really. Okay, if we have time at the end and anybody wants to look at 17, we will come back and look at it, but I'm going to skip it for now because I decided I'm going to skip it on the test tomorrow too. Not because you can't do it, but because it'll save you some time and we don't need to spend a lot of time scribbling. So I'll shorten that on the test for you and not make you do the one that has 2 on the test tomorrow. But if you're just curious on if you did it right yesterday and you want me to look at it at the end, I will if we have time. So we're going to jump on down to 18 now. Ready? 18 says, let me write that equation down that it gave you. That's always helpful. Negative 0.3x squared plus 45x minus 1,000. Alright, so company produces video games, has hired you to set the sales price for its newest game. This equation has concluded where P is the profit in dollars and X is the number of games they sold. What will be its profit if they sell 100 games? So it said X is number of games, so all you have to do is plug 100 in for those X's and let your calculator do the math for you. So you've got negative 0.3 times 100 squared plus 45 times 100 minus 1,000. And then you just type all that in, and I found out that if they sold 100 games, they made a profit of $500. Okay. That's one that'll be pretty easy for you to do, but a lot of times y'all don't honestly try it because it's a word problem. But there was not a lot to do in that. Alright, 19 is the one we had to have the area of the trapezoid that I have over there on the board by Paul. So let's look here. It says a landscaper's designing a flower garden in the shape of a trapezoid. So I just drew the first trapezoid picture that popped in my mind. There are different ways you can draw them, but that's the pretty common one that popped in my mind. So what it said here is designing, she wants the shorter base to be 3 yards greater than the height. So my height here, I needed to label something, so I just labeled it X. She wanted the shorter base to be 3 yards greater than that, so 3 plus that. Then it said the longer base to be 7 yards greater than the height. So 7 plus the height. That gives you, then she said the total area is going to be 150. So that gives you everything you need to plug into that formula over there. 1/2 the height times what you get when you add the bases is equal to the area, which she said was 150. So inside that parentheses, when you add the bases, that 3 plus 7 is 10, and that x plus x is 2x. So now when you distribute that half, everybody's like, oh no, you're going to have a fraction. Well, no, you're not, because a half times 10, that's 5, and it's got an x. And a half times 2, that's 1. X and x is x squared. So you almost now have a quadratic in standard form. Move that 150 over and put these dudes in the right order. X squared plus 5x minus 150 is equal to 0. So now you can do factoring or the quadratic formula. Did anybody get this far on this one and try to solve it? Did it? Okay, I'll do the quadratic formula since that's what Riley said. So x equals negative b plus or minus the square root b squared minus 4ac over 2a. So that's 25 plus 600, which is 625. Isn't that nice? That's a perfect square. Square root is 625. I'll go ahead and show my work so y'all know what to do in your notes. Square root of 625 is 25. So we've got negative 5 plus 25 and divide it by 2. Negative 5 minus 25 and divide by 2. Now this one right here, check this out. This is common sense math. I'm not even going to work that one. Because that negative 5 minus 25 is going to be a negative, and I'm trying to find dimensions of my flower bed. I can't have any negative numbers in that, so I just don't even have to worry about that. Negative 5 plus 25 is 20. 25 by 2 is 10. So x on my flower bed is 10. So that's this measurement right here. Is that what the question asks for? No. The question says how long are each of the bases? So this base would be 3 plus 10, so it would be 13. This base would be 7 plus 10, so it would be 17. So there are your two answers. The rain is here, Grant. At least I think that's what that noise is.
Oh, look. I think it is because my knee hurts.
My knee has been hurt.
That's what weird. My knee hurts.
No, that's actually just true.
It is true.
I know.
Very true.
My foot's hurting.
All right, last one. Let's get this last one knocked out. They got what we need off this one? All right, so gives us this equation.
Yeah.
That's a good one, right?
H of t is equal to negative 16t squared plus 22t plus 6. So it says, to begin the basketball game, the referee must toss the ball vertically into the air. The process can be modeled by that equation where h is the ball's height in feet. Y'all listening? After t seconds. Determine the time interval in seconds in which the height of the basketball is greater than 8 feet. So what we're going to do is take this equation, this inequality, this equation, and we're looking for where it's going to be greater than 8 feet. Okay? So greater than 8 feet now, that's no longer in standard form. I would now need to subtract 8 from both sides. So I'm changing their equation a little bit. That would give me negative 16t squared plus 22t. 6 minus 8 makes that a negative 2. So now we would have it in standard form. Okay? Now notice on this one, the last sentence says round your answer to the nearest 1,000. So this is the only question on this whole test where if it's not a perfect square, it's okay, you can put a decimal. Okay? So I'm just going to go ahead and use the quadratic formula. I'm not going to worry about perfect squares. I'm going to let my calculator give me decimals this time. How did I know to do that? The question said round to the nearest 1,000. So, negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, I just told you we're putting our calculator to work on this. When I did all of that underneath the square root, I just typed it all in and then I square rooted it, and I was looking at negative 22 plus or minus 18.868. I did 3 because it said thousandths, and that's tenths, hundredths, thousandths. All divided by negative 32. Okay, you can test me in your calculator on that. Do all that, and do the square root of it. So now I had to do negative 22 plus 18.868, get an answer, and divide it by negative 32. Then I had to do negative 22 minus 18.868, get an answer, and divide it by negative 32. And this time it didn't bother me about positives and negatives, because when I do a negative by negative, it turns into a positive, right? So I worked all that out, and I got 0.098 and 1.277. So that's in seconds. So that means that I was trying to toss the ball and see when it was going to be more than 8 feet in the air. So that would be between 0.098 seconds and 1.277 seconds. So those are my two answers. The way you would see that written in fancy algebra language would be that your time had to be between those. So it would be 0.098 is less than t is less than 1.277. But if you don't put that on the test, I'm not going to mark it wrong. You can just put the two numbers, it's fine. Oh, I keep forgetting I got this mumbo hat on. I'm like, try to scratch my head. Hazardous. Here we go. Alright, be able to use notes, be able to use study guide. I thought this was one of the easier study guides because when in doubt, you could always do quadratic formula. What y'all think?
Yes, ma'am.
Good? Which guy? Oh, when you plug the 0, you got the 0 from here, so plug that back in. 0 squared plus 3 is 0. So all of these letters is 0. Then you plug in 1 in, 3 squared and 1 minus 3. So you had 3 minus 5. Question.
Yeah, what happened a lot because if I lose this,
I would try.